Next question we have in front of you. In front of you. In the following figure, this is a figure which is given by the question. In the following figure, found out the distance and displacement. Where first distance and displacement for first as well as for second as well as for uh, at angle 60 degree. Here theta is a given. Theta is given which is a 60 degree. Full circle, one complete circle. 1/4 means this one is one part. This one part of a fourth. Of a fourth. We have right now this one, second, third, fourth. But only this. It is this first is talking about this first part. First part. So for this first part, we know distance would be for this first answer is what? Distance will be equal to AB arc. AB arc. So L is equal to theta into R. Theta into R. OA is R, OB is also R. AB is not R. Now for displacement, we have seen a equation which says 2R sine theta upon 2. This is for AB, okay, where two sides are equal to each other. This two sides. So 2 multiple R. R is not given over. This will be our but theta is given. 2R sine theta upon so theta is 90 upon 2 45. 2R multiple sine 45 will become 1 upon 2R upon 2. Okay, this is our displacement where angle is 90. Okay. Even you can simplify it further by doing rationalization. So 2R upon root 2 multiple root 2. We know that we do rationalization so that we can remove root which is a percent in denominator. So root 2 upon root 2. This will cut. Not that. So 2 root 2 into R. 2 to the 4. 4 will be the product of square of 2. 2 will cut this 2. So finally we got root 2R. Okay, this is our displacement from A to B. Okay, this one thing, this is clear. We have done this first. And now second is asking full circle. This full circle. Okay. When it comes to distance, we know distance will be 2 pi r. Yeah, distance will be 2 pi r. Okay. But when it comes to displacement, so displacement of course it should be 2r. It should be 2r. This 1r and this. So from here to here, this 1r and this. But remember, it came again to the initial point. That's why displacement will become 0. Because it came to the initial point. Clear? So displacement will be 0. Okay. Finally, here we are right. Okay, we are correct. So third, given distance, but theta is provided by this question. Theta is which is 90. So theta is multiple r is how much? R is nothing. So theta multiple r will become our distance. Will become our distance. There is also half circle, half circle, half cycle, half cycle. There is also half cycle. For this distance will be pi r, and displacement will be 2r. Okay, this was two second, third, and this is a fourth. Half circle. For half circle, distance is going to be pi r and displacement is going to be 2r. Fourth is in fourth, this fourth. Angle into radius. So angle is over here, pi upon 3. Just we converted this degree into radian. Pi upon 3 into r, which is a pi r upon 3. This is our radius. Even you can substitute the value of pi as 180. 6 3s are 80. 6 3s are 80. Over here theta was 60. So just your work is to convert this theta, which is a 60 degree, convert it into pi, radian, pi upon 3. So 180 upon 3, we will get 60 degree. So just we are putting this 180 as a pi. So pi upon 3 is the angle of this figure. Radius will be as it. So finally distance is a pi r upon 3. Now what about displacement? So displacement where theta is 60 degree. We have seen already, brother, but over here we substituted 90 degree. So 2r sine 60 upon 2. So 2 will be as it. R is not given. R is not exact value. This is value. 2r sine 30. So value of sine 30 we are already crystal clear about it. So 2r will be as it. Sine theta 1 by root 2. Again 2r upon root 2. But hold on. 1 by 2. Only 1 by 2. Okay, only 1 by 2. So finally we got r as a displacement where theta is a 60 degree. So at over here, let's say this is a 60 degree. So it is saying whatever will be value of this radius, for instance it is a 5. So from here this displacement, this will be also 5, which is equal to radius. Okay, that is what we are interacting with this radius answer. Okay, with radius answer. Finally this question is completed. Now let's move towards the questions. is the question's answer? Question is x is equal to 4 minus 60 plus t square, comma x is a meter. X is a meter, and we will consider t as a second. Then they find the distance. Then they find the distance and displacement. Distance and displacement. Okay, this is our question, where time is equal to t, which is equal to 0 to is equal to 4 seconds. From 0 to 4 seconds. First is 10 meter minus 8 meter. 10 meter and minus 8 meter. Try to understand. X, which is a location of let's just say there is a particle. There is a location of a particle which is this. X is equal to 4 minus 6t plus t square. We can decorate it in a right arrangement. So it will become t square minus 6t plus 4. Okay. So x, we will consider this x in meter. Okay, x in meter and t is in second. Then we find the distance and displacement. We will have to calculate two things, which are distance and displacement. Time is from 0 to 4 seconds. 0 to 4 seconds. Okay. 10 meter minus 8 meter. 10 meter minus 8 meter. What did you understand? Whatever is given by the equation, just write. Okay, just write. So x is given 4 minus 60 plus t square. You can differentiate this. I know. So velocity will become, we know relation of xt is for velocity. Relation of vt is for acceleration. We are familiar with these things. So axt will give us what? The velocity. So for a current location, for instantaneous velocity, we know that v is going to be equal to dx upon dt. Yeah, dx upon dt. So x is how much? 4 minus 60 plus t square. Okay, no problem. So differentiation of 4 will become 0. Differentiation of 6 will become 60 will become minus 6. I think minus 6, because of there is only t. So minus 6, and differentiation of t square will become 2t. So this became our v as 0 minus. So we can it can be written as minus 6 plus 2t. Minus 6 plus 2t. If you differentiate this v, then acceleration will come. Acceleration will come. Let's say velocity is 0. Which means object is coming to rest. So this will become 2t minus 6 is equal to 0. Okay. So t will come. Here we are finding time. where object came to rest. So at what time object came to rest? So 2 is equal to 6, so t will come as a 3. At 3 second, object will come to rest at 3 second. Okay, clear? At 3 second, velocity will become 0. Velocity will become 0. Now, means body turn out t is equal to 3 seconds. Remember, we are not taking this as a, yeah, but for little bit, velocity will become 0, but not exact 0. Means when a turn will come, for vehicle, then of course that vehicle will decrease the speed when it comes to turn. So we are talking about the turning point, turning, okay, turning. So we are understanding at 3 second velocity will become 0. That is what we are understanding. Tell me, so at 3 second, at 3 second, 0. If we put 0, this t as a 0, so we will get x as a minus 5 meter. X as a minus 5 meter. X as a minus 5 meter. T is equal to 0. Minus 6, 0. So V is coming as a minus 6. But we will substitute value of t over here in this equation. So this 0, this term will become 0, this will become 0, so x will come as a 4, as a 4, as a 4. Yeah, over here, this will be 4 meter. So over here, t is equal to 3 second. So over t 3 second, x will become, if you substitute a value of 3 over here, 3 3 is a 9, 6 3 is a 18. 4 minus 6 3 is a 18 plus 3 3 is a 9. 4 minus 9 minus 5. It came as a minus 5 meter. Here x is the location of a particle at this much time. Then t is equal to 4 second. X will be 4 minus 6 multiple 4 plus 4 raised to power 2. 4 minus 24 plus 4 is 16. 4 minus 8 will become minus 4. Minus 4 meter. Now let's draw a figure or a Cartesian horizontal line so that we can analyze, we can find exact distance and displacement, exact distance and displacement. Negative number is a minus 5. From minus 5, minus 5, we will start from minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, till the 5, till the 5. X is equal to. These are numbers of X, location of a particle. Initially t is equal to 0, object is over here. This is initial point. T is equal to 0 and x is equal to 4. X is equal to 4. Initially was over here. Initially was at 4. Now t is equal to 3 seconds. 3 seconds. Particle, but over here 3 is equal to 4 seconds. 3 is equal to, time will be, of course, time will be positive. Time cannot be negative. So here t is equal to 3. Particle came minus 5 over here. It started moving from here and it reached over here. Okay, like this. Now t is a 3 second. Then and x is a how much? 5 meters. Last t is equal to 4 second. Object came over here like this over here. Minus 4. T is a 4 second and x is a 4 meter. Not 4 but minus 4. And here it is a minus 4. Yeah, finally we came to the main point. Distance will be how much? From here 1, 2, 3, 4, 5, 6, 7, 8, 9 and one more 10 meter. It covered a 10 meter distance, but when it comes to displacement, then shortest path, we say shortest path from here to till here. Initial point is there, this is our final point. We will ignore this part, okay? So from 4 till the minus 4. 1, 2, 3, 4, 5, 6, 7, 8 meter. 8 meter. But hold on. Negative is a violet for displacement. So final position of the particle is a minus 4. And initial will be 4. Here words is 0. But this is not our answer. Our answer will be 8. 8. Direction is a compulsory for displacement. As we know, displacement is a vector quantity. That's why. So direction is a positive in this direction. This is going backward, not forward. Okay. So displacement will come 8 meter. And distance will be 10 meters. So finally we got this thing. We would like to repeat these things that we brought, steps that we brought. (10 meter, 8 meter). This is our answer, isn't it? 10 meter is the distance, displacement is minus 8 meter. Yeah, this is our answer. Yeah, okay. Now, let's understand again. This is our answer, brother. answer. Which was the option? Question was asking location of a particle is given, which is a 4 minus 60 plus a t square. This is the location of a particle, where we will have to consider x, this x in meter, this in meter, and t in second. Then find out this two things, distance and displacement. Time is given, which is from 0 to 4 seconds. From 0 to 4 seconds. Main thing is when it comes to distance, then we think our focus will be on turning point. Okay, at what second the object took a turn. Okay, took turn. This turning point is compulsory. So for turning point, we assume let v as a zero. V as a zero. So we are at the turning point. Of course, object will decrease velocity at zero velocity. Okay, it is impossible. If we are driving with some velocity, and if we think here turning is coming, and velocity will be this much, which is initial, then accident will happen with you in real life. We wrote this as it. Then we found what? We found the velocity after differentiating it. Dx upon dt, x was given. Then we got v as a 0 minus 60 plus 2t. We put v as equal to 0, so that we can found at what second velocity will become 0. We will consider this as a turning point. So at 3 seconds we got v as a 0. Then just we just put this t is equal to 3 seconds. T is equal to 0. In this we got x as a 4. We put just t is equal to 3 in this equation. We got x as a minus 5. Then t is equal to 4. Then we got in this equation x as a minus 4. By the help of this thing, we were able to draw this line. Initially, object was over here at 4. Then he went till the minus 5. Over here he took a turn, and then he covered how much? 1 meter distance. So as we know, distance is actual path. Actual path is from here, then 1 meter more. Displacement is from 4 till the minus 4. We applied this minus for direction. This is our final answer. Okay. Now let me write next question. Have a look for few seconds. I am giving you time so that you can get understanding more. Let me reach. Next question. motorcyclist follow straight line L meter and turn left side by 60 degree and repeat it then displacement. Fifth term. Figure is not given by the question, but don't worry, we can draw figure. Motorcyclist follow straight line. Let's say this is a straight line, okay? A straight line. L meter. We can consider this as a L meter. L meter. Then turn left side. Left side. This side or this side. So left side. This turn by 60 degree. How much? This angle is how much? 60 degree. Rather than going straight, he turned in this direction. Left side, not right side. With how much rotation? 60 degree. And repeat it then and this is a repetition. Again repetition. 60 degree, then straight turn, then 60 degree, again 60 degree, then straight. Like that. Okay. So over here, this will become 60. It is straight. Then over here, this will become our 60 degree. This is our 60 degree. We are considering this as a first turn and this is second turn, this third turn, fourth turn, fifth turn, and then sixth turn. This is the first turn. He took a turn at 60 degree. At how much? 60 degree. Okay, so finally till here we have understood. Then we have to calculate the distance, and first of all distance. Then displacement just after first, second and fifth turn. When it comes to distance, we just add, okay, just actual part. This one is how much is 1, 2, 3, 4, 5, 6. So it will become 6L. Okay. For example, L is 5 meter. Then this will become 6 5 or 30 meter. 30 meter. How much? 30 meter. What brother? Just after first, second, and third. So at first turn, what will be our distance and displacement at first turn? Okay, at first. So distance will be how much? I think if it is taking 2. So first will be L. Only this. First L and this is straight L. From here we have said that distance is equal to displacement. It is a fact. This is fact. Now when it comes to after second second term. After second term, then our distance will be 2l. But displacement will be something else. Displacement will be something else. Where theta is a 60 degree. Here is a twist. Here is a twist. You can't say that 2l is equal to displacement. No, not at all. Not at all. Brother, two sides values are provided by the equation for two sides. This one, this is second. L, then again, and theta is also given. When it comes to this one, this, of course, it will form a triangle. For this is say that L square plus 2 L square cos how much? 60 degree. Cos 60 degree. This will become 2L square plus 2L square cos 60. Cos 60 is known as, but hold on. 2L square is a common, 1 plus cos 60 degree. Cos 60 degree. So 2L square cos 60, 1 plus cos 60 is known as 1 upon 2. 1 upon 2. Can you write 1 upon 2? 2 plus 1. 3 upon 2. 2L square 3 upon 2. This will be your displacement. Here you can simplify it further. It is in your hand. This is your work. Ahead of it, you can solve it. Till here, this is the correct. 60, 1 upon 2. Now let's find after fifth term. After fifth term. Third is after fifth term. So of course distance will be fifth. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Fifth term. So distance will be 5 here. And displacement will be how much? Displacement will be from here to till here, like this. Again, theta is how much? Theta will be our how much? This will be 120. 120. You can see. $120. So displacement will come as a L. One, 2, 3, 4, 5, 6. I think it took this. If this, then okay, displacement will be A. Now next question. Next. Next is wheel of radius R is rolling in forward direction. Positive x-axis. Found the displacement of P where it reach to the highest point. Initially, this was over here, where P is like this. Then it became to this is a complete question. Complete question. It's not a difficult to solve this kind of a question. Wheel of a radius. Let's say this is a circle. This circle is wheel. Initially, circle was over here. Wheel was over here. Wheel of radius R is rolling in forward direction, not the backward direction. So this point is like this. So it went over here. It went when it rolled, then P came over here. This is what is happening. Okay. Direction. Find the displacement of a P. This is a displacement. So displacement is nothing but this straight line, shortest path. This will be our shortest path. Displacement, isn't it? This will be our displacement. But when it comes to distance, we know this will be our half circle. Half circle will be our distance. This half circle will be our distance. So distance is nothing but distance is to pi r, only pi r, half circle. From here to till here. Okay. It is not asking this 2r. This is asking this displacement. Hypotenuse. Let's say this point is A, B, P, A, B, C. Okay. So BC is our displacement. BC our is a displacement. Total circumference will be 2 pi r, but half will be pi r, which is a distance we have written already over here. Okay, half of the total circumference will be pi r. Okay. But when it comes to displacement, then it is talking about this thing. Tell me, if it is a hypotenuse, can't you say that this sum of this side and this side will be equal to BC, where it is forming an angle of 90 degree. which is perpendicular to AC. Okay. So finally you can write like this: AC square plus BC square is equal to BC. AB square is equal to BC square. Okay, so this will be our pi r square. Pi r square. Why pi r square? And this will be our 2r square. So this will become 4r square. 4r square. Right now just understand this is our 2r square. This we took how much? Pi r square. Pi r, not a square. Pi r. Why pi r? Just it is a half circumference. Half circumference, okay? This is a half circumference. So pi r square plus 2r square is equal to BC. So again pi r square is equal to 4r square. 4r square. In this equation, r square is common. R square is common. Pi plus 4. R square was common. R will come out over here. Then finally our answer is pi plus 4. Pi plus 4. But remember, this will be our pi r square. Finally, this is our displacement. Now again, distance will be, this will be our distance. Distance is just a half circle, but displacement is a little bit different from the distance. So displacement will be equal to just it is a hypotenuse. We are considering this as a hypotenuse. So why hypotenuse? Because of this angle is forming of 90 degree. That's why we are able to apply Pythagoras theorem. Sum of this side and this side will be equal to third side. So we got this as a pi r. Why? Reason is it is just half circumference, nothing else. And 2r is already given. If this were not given, then we were able to find 2r. How? This 1r and the second r will become 2r. And then after simplifying this equation, we got this one, r under root of pi r square plus 4. Okay. Now next question. The next question is if x is given 60 square plus 90, then distance will be t is equal to 0 from so from t is equal to 0 to t is equal to 5 seconds. What will be our distance? Only distance, not a displacement. And question knows that it is a difficult from the displacement. We will solve x is the location of a particle. Okay. and we will have to start from 0 second till the 5 second. 5 second. You are crystal clear that a relation of xt gives us a velocity. So here over here x is given dx upon dt, dx upon dt. Okay. So t raised to power 3 minus 60 square plus 90 upon dt. Okay, brother. Okay. This will become 3t square minus 12 t square plus 9. This is equal to b. Now over here we are taking v as a 0, so that we can found a turning point. Turning point. Turning point. Okay, turning point. At what second will v will become 0? 0 is equal to 3 raised to 3t square minus 12 t square. But hold up. 12 t plus 9. Here 3t. This is our quadratic equation. Quadratic equation. Isn't it? Quadratic equation. But 3 is a common. T square minus 4t plus 3. 3 is a common. So t square minus 4t plus 3. Again, t square will be as it. T is a common. T minus 4 plus 3. 0 t minus 4 plus 3. T will come as a plus 4 minus 3. T came as a 1 second. 1 second. At 1 second, velocity is becoming 0. 0 meter per second. Okay. At 1 second, velocity is becoming 0. But t square minus 4t plus 3 is equal to 0. t minus 4 plus 3, 0. t minus 4 is equal to minus 3. T minus 4 is equal to minus 3 upon t. This is what is happening. Just to understand, at 0 second, x is 0. At 1 second, x is 4. At 3 second, x is 0. At 5 second, x is 20. X is 20. Now we are going to draw a line. Minus, there is nothing minus. Let's say this is 20 meter. 0, 0, 4. This is 4. At 0 second, line wise we will go at 0 second. uh, Location of a particle is over here. It started just from over here. So then at 1 second he went at 4, like this. 4. uh, where t is a t is a 1 second. Then again uh, it went at 0 at 3 second, at 3 second. Then he moved from here. He went till the 20, like this, till the 20. This was our initial, and it is our final. This is our final, where x is a 20 and t is a 5. T is a 5. So distance will be this 4 for 8 plus 20 will be our 28. Displacement will be our nothing. Displacement will be our 20 from initial to final. 20 meter. 20 meter. Meter. Now next question is the position vector of a particle is determined by the expression which is r vector is equal to 3 t square I cap plus 4 t square j cap plus 7 k cap. The displacement traversed in first 10 seconds will be what? How much better? Look at over here. It is asking what? What is it asking? It is asking the position vector, which is the R1. Position vector of a particle is determined by the expression. This is the position vector of a particle, which is a 3t square I cap plus 4t square j cap plus 7k cap. The displacement traversed in first 10 seconds means from here to till here this is a particle and it moved over here. What is this displacement which that particle moved? Okay, okay, so it is asking this complete delta r vector, delta r vector. Clear? Delta r vector. We know delta r vector is nothing but r2 minus r1, final vector minus final position vector minus initial vector. Okay, first of all we will find initial, then final, then final. And initial will be our how much? Initial where t is equal to 0. T is equal to 0. We are putting t is equal to 0. So initial will be our 7k cap. 7k cap. How? Let's see. At t is equal to 0. At t is equal to 0. So this term will become 0. This term will also become 0. But when it comes to this term, there is a no t. Okay, that's why this will exist. This term will exist. So r final where t is equal to 0 is at 7k cap. Okay, okay. Final time is a 10 second. Okay, where we will put t as a 10 in this position vector. In this position vector. So 3 multiple 10 to the raised to power 2 plus 4 multiple 10 raised to power 2 plus 7 plus 7. 3 multiple 100 plus 4 multiple 100 plus 7. 300, 700, 707. 707. You are understanding our final is over here 707 k cap. 707 k cap. But not k cap. Okay, not k cap. We have this 300 I cap plus 400 z cap plus 7 k cap. Try to understand. Initial location of the particle is at 7k cap. Final location of a particle is at this location, which is a 300 I cap plus 400 j cap plus a 7k cap. Okay, okay. Now it is asking when he moved from here to till here, so how much he covered distance? That is what he is asking. Okay. Complete total delta R. Total delta R. To calculate delta R, we have this simple formula. Final position vector minus initial position vector. So final is 300 I cap plus 400 z cap plus 7k cap, or over here initial is just 7k cap. So finally we got 300 I cap plus 400 z cap, which is total. Yeah, total. But we want only magnitude, not a direction, so that we can get exact displacement. So we are going to apply mode. Okay, mode. Okay, so that we can get only magnitude. You know, this raised to power 2 plus this raised to power 2 and under root will be our final magnitude. Clear? So R will come as a delta r will come as a 500 when you will simplify this equation. So 500 meter is our, this is our complete displacement. Okay, complete displacement. Let's visualize these things. Look at over here. Location of a particle initially is over here, which is a 7k cap. This is an initial location. Okay, I am writing complete. And then he covered some distance, and that is what we have to calculate. And finally, we calculated, which came as a 500 meter. So final location of the particle in the language of vector is how much? 300 I cap plus 400 z cap plus 7k cap. Yes, but displacement will come like this. Final. This is final. Yeah, final. So final minus initial, we will get displacement, which came as a 300 I cap plus 400 z cap. But problem over here is it is in direction. We wanted only magnitude. For that we just use mode, and when we use mode, we know that this all terms will come into under root with a square. Okay, x raised to power square I cap plus y raised to power square. Then we got this much displacement as a magnitude without having direction.